Hello. Is everyone having a good show? Hopefully you've already learned a lot. Hopefully it's been an exciting event. We've got a lot of really cool stuff that we've been talking about. So really happy to be here. So for those who don't know who I am, hopefully most of you do know who I am, but I'm Ben Armstrong, program manager on the Hyper-V team, and this is...
Hi, I'm Sarah Cooley. Most of you probably don't know who I am, but I work for Ben Armstrong.
So Sarah has been working on the team for a while, and she's actually going to be joining me today to talk about some of the features that she's been working on. But before we get to that, just want to kind of set the scene, talk about what we're going to be talking about today, and let you know what you're in for. So what is this session about? This session is me trying to give you a quick drive through all the features and things that are in the Technical Preview 2 build that you can play with. So this is going to be a very demo-heavy session. We have 14 demos, about half an hour of demos, so we're going to be talking fast and showing you features and showing how they actually work. It's not a complete overview of everything that will be in the release. We're just focusing on, like, we just released the Technical Preview 2 build. What are you guys going to be able to go back home and actually play with, use in your labs, do evaluation on? That's the real focus of this session. Another thing to highlight, a lot of these features are in Windows 10, and as we're going to be going through, I will try to call out, hey, this is in Windows 10. Some of them aren't in Windows 10. I will attempt to call out which ones are server only and which ones are available in Windows 10 as well. If I miss one, please feel free to ask me at the end and say, like, hey, feature X, is that feature available on Windows 10 or is that a server only feature? We'll try and call that out as we go. Two things I want to talk about before we get into the actual feature discussion. The first one is NanoServer. So how many people here have been to the presentation, seen discussion of NanoServer? Fantastic. This is really exciting stuff. And this is actually something that we on the Hyper-V team have been working really hard on to get Hyper-V up and running. So many late nights trying to get builds working and get everything functioning. So one of the key things that I want to highlight here is that all the features that I'm going to be showing you, we're working to make sure they all work on NanoServer as well. And we're really excited to have NanoServer as a great way to deploy Hyper-V. And we're going to be encouraging everyone we can to start looking at using NanoServer for their Hyper-V host environments. Next thing to just touch on is the container work. So how many people did not leave this room and were in the previous session on containers?
Awesome.
Fantastic. I looked at the schedule for today, and I'm like, I'm sure there are going to be people who are just in this theater all day long. The Hyper-V team's been very heavily involved in containers. I'm not going to be talking about that today for two reasons. One, we just had a session on containers. If you weren't here, there's a great video that's going to be online that you can watch for all of that. And two, because I'm focusing on things that you can play with in the Technical Preview 2 build. And containers will be coming out in the future. So with all that said, Sarah, do you want to take a seat? Because your session comes up later. By the way, this is Sarah's contribution to my deck. You'll see all the stick figures on the slides. We put the slides together. They were very basic. And I said to Sarah, if there's something you can do to make my slides like flashier and more impressive, and this is what I get. So I'm going to be talking about a lot of features, but really, and hopefully unsurprisingly, almost everything we do on the Hyper-V team, we're focused on what can we do to make cloud computing great. And when I say cloud computing, I really mean all forms. I'm talking about what can we do to make the hyperscale cloud that we run on Azure on Hyper-V awesome. I'm talking about people who are running large hosted clouds and providing as a service. I'm talking about enterprises, and I'm talking about those of us who, I like to joke, I have a cloud in my closet at home. I have, just a handful of Hyper-V servers, but I play with all the technology. And we look across that whole group and go, what can we do to make cloud great? And there are a whole bunch of areas, and this is just, I'm going to be drilling through these and talking about these areas as we go. So next contribution from Sarah is security. So get your tinfoil hat on. We're going to talk about some of the security work we've been doing. So before I get to the demo, got a clicker problem. There we go. One of the things that we are very aware of, we've spent a lot of time talking to people about cloud computing, talking to people about the efficiencies, about how they can change their business model, about how they can save money, be more agile, all these great things about cloud computing and all the awesome technology that we're doing in Azure and we're enabling through Hyper-V and our cloud platform. And the reality is, whenever we talk to customers, the number one thing that is holding them back is the issue of trust. People, and I understand this, I have this myself, you want to know that your data is safe. You want to know that no one else is accessing it. You want to know that it hasn't been fiddled with, it hasn't been compromised, that you're the only person who has access to that data. And so we're doing a lot of work in the core platform to start providing these guarantees. So with that, I'm going to switch over and do my first demo. So what I'm about to do is I'm going to use remote desktop to connect to a virtual machine that I have running on another computer. I actually have multiple laptops up on stage to do all these demos. So it's a bit of a wiring mess up here. But this is a virtual machine that I'm running the Technical Preview 2 build in. And I'm just going to bring up Device Manager first to show that, yes, this is a virtual machine. If you have a look, you can see all the Hyper-V devices in there and so on. But more interestingly is that this virtual machine has a TPM. So this is a virtual TPM that we're projecting into the virtual machine. So why does that matter? Well, the reason why that matters is that enables me to then go ahead and enable BitLocker inside this virtual machine and protect my data from anyone outside of the virtual machine. So I can now have this virtual machine, have it be running on someone else's Hyper-V server, on someone else's infrastructure, and I can know that I'm the only one who has access to that data. So this is really exciting technology to be bringing out. This is in the Server Technical Preview 2 release. Another thing, little different tweak on security, is some work that we've been doing with Linux, enabling the secure boot functionality. So while I bring this up, let me just do a quick show of hands. How many people here actually know what I mean when I say secure boot? Okay, I'd say about 2/3. For those of you who didn't show your hands, let me just take a moment and explain. Secure boot is an amazing feature that is so underrated in the world today. When we look at security issues at large, one of the biggest challenges out there is malware and rootkits. And in fact, session after this is talking about malware hunting. And one of the challenges is if you get compromised kernel mode code on a system, there is pretty much nothing you can do to bring that system back. At that stage, your only option is to format and reinstall. What Secure Boot does is it allows the hardware to verify that the kernel mode code is uncompromised. So when we released Windows Server 2012 R2, we had Generation 2 virtual machines. We supported Secure Boot for Windows guest operating systems so that you could have this functionality and know that your workloads were secure. We've been working with the Linux community. We now have support for Secure Boot for Linux virtual machines as well. So you have the same level of protections and guarantees. So if I just bring up the settings on this virtual machine, you'll see that Secure Boot is enabled. Obviously, I have Linux running, and I have a very complicated script. No, it's a one-liner that's will just tell me, hey, Secure boot is enabled. This is a protected system. The kernel that's running in the kernel mode code is all the code that we expect to be running. So those are two features. Let me jump back here. To go a little bit deeper, so the virtual TPM functionality that I showed you is part of a larger security story that we have, which we're calling shielded virtual machines. And the end-to-end story that we have here actually involves System Center Windows Server Hyper-V to deliver an orchestrated experience for providing highly secure and protected virtual machines. Now, unfortunately, a session going deep on this is happening right now. So I promised them that I would say, if you think that this is more interesting than the rest of the stuff I'm going to talk about, you have 2 minutes to leave. In the next 2 minutes, if you get up and leave, I won't hold it against you. After the 2 minutes, I will judge anyone who leaves. You stay for the ride. But it's unfortunate that that's happening. However, it is being recorded, so I'd really encourage people to look at that session. Lots of great technology coming along here. The other thing that I showed was the secure boot support for Linux. Right now, we have support for this for Ubuntu and SUSE. Different Linux distributions need to decide when they're going to pick up the code for this and take it. One thing to be aware of is that in order to use this, you have to change the secure boot template on your virtual machine. Had a couple of people confused about this. They go and they try and install Linux in a Generation 2 virtual machine, and we come up and say, hey, that's not right. It's because we're trying to compare it to the certificate for Windows. You need to change it to the certificate for Linux that we use to compare. Also, a call out that we have a session tomorrow that's going to be going deeper on virtualizing Linux and FreeBSD with Hyper-V. So, that's security. What beyond security? Well, the next thing we look at is isolation. Now, this might sound a bit strange to you because isn't isolation what virtual machines are about? You know, that's why we put things in virtual machines. It's to isolate them. And yes, this is true. You know, the heart of virtual machines is that we isolate the code for different running applications from each other. But what we're finding is that as people are putting more and more workloads in virtual machines, and as we're getting these larger and larger systems, that just isolating the actual running code is not enough. We need to start to ensure that we isolate the performance and guarantee performance, and that different virtual machines cannot affect each other's performance. So a big investment that we've made in this area is in the storage QoS feature. So I'm going to jump over this slide and go to a demo so I can talk about this, and then I'll jump back to the slide. So let me start up the storage QoS demo. So in Windows Server 2012 R2, we provided the first controls for storage QoS, where on a per virtual hard drive basis, you can go in and you can specify a maximum storage QoS limit, and we will restrict the virtual machine to that. So in Windows Server 2016 and in the Technical Preview 2 release, we're taking that to a whole new level. So let me log into these two machines quickly. This is the hard part where I have to try not to say my password into the microphone. I'll give you a hint, it's password. This is a demo system, so doing low security on this. So I'm going to start a workload in this first virtual machine that is just going to come up and go as hard as it can and utilize all the bandwidth that's available on my storage. And maybe I'll get the password right. Did I get the user wrong? Yes, I got the user wrong. So I've got this first virtual machine going. It's using all the bandwidth that it can. But now I'm going to go to the second virtual machine. I'm going to do the same thing. Now these virtual machines are configured to use virtual hard drives that are sitting on the same scale-out file server on the back end. And what you're going to see is that as the workload comes up, they're going to start competing for bandwidth. So there we see, nice even display. But I have a storage QoS policy that is actually defined on the scale-out file server. And that storage QoS policy says any disk that's assigned to this policy, sum total can only use up to 1,000 IOPS. So I'm going to run a script, and what this is going to do is it's going to take the virtual hard drive for this virtual machine and assign it to that policy. So OK, it's now gone down to around 1,000 IOPS, and the other virtual machine has picked up. Great. Well, this is what we could do in 2012 R2. But in the Technical Preview 2 release, what I can now do is I can actually say, you know what? Both these virtual machines belong to the same guy. So same policy, he only gets 1,000 IOPS no matter where he's running the workload. So now, both virtual machines are collectively capped to 1,000 IOPS. Other workloads are unaffected. But the guy who owns these two virtual machines gets to decide where the workload goes. So if I then come over here and stop this workload, what you're going to see is that my first virtual machine is going to get the IOPS back, so it'll be able to go up to 1,000 IOPS and get the bandwidth. So this is really useful when you're talking about multi-tenant and multi-distributed application environments, where you can now start to say, you know what, like this multi-tier application, collectively it only gets 5,000 IOPS. You know, that customer, they're only paying for 2,000 IOPS. I don't care how many virtual machines they have, that's the limit. So this is just taking it to the next level of control. So let me stop that, and we'll jump back to the slide. Another feature, I'm not going to demonstrate this today because it's a bit tricky to demonstrate. We actually demonstrated it accidentally at TechEd Barcelona. But this is a really neat feature that we have built for Azure, and we're actually enabling it in the Windows Server Technical Preview 2 release. And it's a feature that we call host resource protection. Now, the thing to understand here is hopefully this won't surprise you, but there are lots of people out there who every day are trying to attack Azure. We have lots of people getting VMs in Azure and trying everything that they can to try and break out of those virtual machines and cause mischief. Now, thankfully, we've written good code and no one's ever gotten out. So that's a good thing. Virtual machines are doing what they're supposed to do. However, one of the problems we've seen is that when these users are in there being malicious, trying to break out, they quite often chew up a whole lot of resource as they're doing these crazy things. So what we've actually done is we've been working with the Azure team to build heuristics in where we've identified patterns of access that should never happen if someone's just running standard Windows applications or Linux applications. And we've looked for patterns of access that show that, like, okay, they've loaded third-party kernel mode code and it's poking at things that aren't there and so on. And we now dynamically detect that. And what we'll do is we'll just throttle back the resource on that virtual machine to reduce its impact on the system until its behavior returns to normal. So this is something that you can enable or disable on Hyper-V. In the server build, we've got it enabled by default on Technical Preview 2. For most of you, you should never see this. Hopefully no one's running malware in your virtual machines and doing evil things. If this does happen, you'll actually see a status in Hyper-V saying that host resource protection is enabled on that virtual machine. So, moving on, the next thing. This is the biggest thing I have to talk about. Every time that I come and do one of these events, I talk about what are we doing to keep virtual machines running. And there's actually a whole lot of technology in the Technical Preview 2 release to make sure that your virtual machines are running more often and that you turn them off less and less frequently. So, the first thing I'd like to talk about is a bunch of features that we have, which we call our resiliency features. And I gotta say, Actually, let's start off with a nice show of hands, because I know the result, but I have to ask. How many people have ever had a moment in their environment, whether it's production, whether it's their lab, whatever, where one day, one afternoon, for no reason whatsoever, the network just went away for a minute? Yeah, it happens, and it'll come back, and you have no idea. Like everything's running along, and then all of a sudden, no one can see anyone, and nothing's working, and you don't even get time to look into it, because by the time you realize something's gone wrong, it's back. And you're like, well, that was weird. Now, the problem is when that happens in your cloud fabric. So when that happens, we have clusters where all of a sudden the nodes can't see each other. And we have nodes where all of a sudden they can't see their storage. And today, this is a big catastrophic event. Because in all these situations today, Windows clustering and Hyper-V, we tend to panic and be like, we have to try and fix everything. And the network comes back, but by the time the network comes back, we've actually caused more harm than good in our mad panic to get everything fixed. So there are two features that we're doing in Technical Preview 2 to make us more resilient to these sorts of transitory failures. The first one is a feature called Virtual Machine Storage Resiliency, and the second one is Virtual Machine Cluster Resiliency. So I'm going to switch across now, and I'm going to demonstrate these two features. This, by the way, is my scariest demo. So I just want to get that up front. Because the first thing I'm going to do, this script is going to run, it's going to set up a virtual machine which has storage running on a scale-out file server, and we're going to break the scale-out file server. And everything's going to work. You can trust me. This is going to be great. Sarah can tell you I have practiced this demo so many times. So here we go. Log in, and I'm just going to start a simple file copy. So I've got a nice little, let me zoom in, nice little file copy going on. And then I'm going to come over here, and I'm going to disconnect the storage. Okay, so the storage is being disconnected, and what you can actually see here is VM seems to be running, but nothing's happening. So what's going on here? And let me just show, it's responding, but the file copy stopped. So what you're actually seeing here is functionality that we shipped in 2012. So when we released the 2012 release, we had a feature in scale-out file server that we called resilient file handles. And resilient file handles give you protection against really short storage outage. So even today, if you have a glitch in the system that causes storage to go out for 30 seconds, 40 seconds, resilient file handles will have you covered. And we buffer up the activity, we wait for it to come back, and we reconnect. The problem is if that storage outage goes over 60 seconds. So today, you have a storage outage that goes over 60 seconds, resilient file handles will go up to 60 seconds, and then we'll just return an I/O failure back to the guest, at which case, 9 times out of 10, it just crashes. So with the storage resiliency feature, now, when the resilient file handle expires, and we get that storage failure, rather than returning it to the guest, we automatically pause the virtual machine. We put it in a special state to indicate to you that, there's a disk failure, but we suspend it and make sure that it doesn't crash. So here you can see I've now got disk-encountered critical I/O errors. The virtual machine is paused. And so if I try and go in, it doesn't respond. It is in suspended animation. I can come back here, and I can restore network connectivity. And what you'll see is very shortly, we'll automatically detect this, we'll unpause the virtual machine, and the file copy will pick up. So the great thing about this is you can imagine, like, if you think about what we have with 2012 R2, you have a storage outage at 2 a.m. in the morning, you're going to have a very bad day. With the Technical Preview 2, you can have a storage outage and have it recover and fix itself without you ever knowing about it, because this all happens automatically. So that's the storage resiliency feature, which I think is really cool. I'm really excited to see it coming out. Now I'm going to switch over and show you the cluster resiliency feature. This just has to do some cleanup. This is where I have a million VMs for all these demos. So this is going to do some work to set up my cluster and get it in the right state for me to be able to show you this feature. But this is coming back to us talking about what does clustering do when you have a transitory failure in your network. So just going to bring up the tool so I can show this to you. So, and today, when we see these transitory failures, the moment that clustering can't talk to a node, it assumes all the virtual machines are dead, and it starts failing them across to other nodes in the cluster. And we're changing that and all the behavior around that in the next release of Windows Server. So if I come here, you're going to see this is a test cluster, so I only have one running virtual machine, a bunch of offline virtual machines. I have 3 nodes in this cluster, and that running virtual machine is on demo laptop 2. And what I'm going to do is I have my script is just going to go and kill the clustering service on that laptop. Now in the past, all the VMs would have been failed over, even though the VM's still running happily. Now what we've done, we've put that laptop, that cluster node, into an isolated state. We've marked the virtual machine as unmonitored, and we're just going to wait a little bit to see if it comes back naturally. So by default, we're setting this timeout to 4 minutes, and if it comes back in under 4 minutes, we're just going to join it back to the cluster and heal automatically. So now it's joined back to the cluster, the virtual machines, in a good running state. Now, that's great, but what if you have a cluster node that is having intermittent problems? Like it's coming, it's going, it's coming, it's going, it's causing problems in your environment. Let's imagine that you just have a damaged network cable, or you have some failing hardware. Well, we have a second layer of detection, which I won't be showing today because I have too many demos already, where if that happens, we will detect, hey, this cluster node has gone into isolated state too many times. We mark it quarantined. When it comes back, we will automatically live migrate all the virtual machines off of it and then say, okay, we're not putting workload back on that cluster node until it looks like it's healthy again. So that's the cluster resiliency feature. Let me get rid of that and jump back. What other features are we doing for availability? We've got a whole ton of features for availability. So here's a question. How many people are using shared VHDX? Good people. I'm happy to see that. So shared VHDX, great feature that we did in 2012 R2, makes it so much easier to set up and do guest clustering. However, and this was intentional. We made a decision when we were working on this. We're trying to figure out how to scope it and so on. In the 2012 R2 release, when you create a guest cluster with shared VHDX, you pretty much have all the limitations of any other guest cluster, with the exception that it's just using a VHDX. But features that you don't get with guest clusters that you get with standalone virtual machines, like host-based backup, like online resize of virtual hard drives. All these great features aren't there. So in the Technical Preview 2 build, we're working hard to start bringing all those capabilities back, even when you're using shared VHDX. So the 2 big things that I'm really happy to talk about, the first one is we're going to allow you to do host-based, no agent in the guest backup of guest clusters with shared VHDX. So this is something we're working with our backup partners to enable. And I would really encourage that, like, whichever backup partner you're using, you should be talking to them and saying, like, hey, can you get me, early access to a build with this functionality? We're working with everyone so that this is going to be super simple and super easy to do. The next thing is we're going to allow you to online resize shared VHDX files. So I'm going to switch across now and show you what that looks like. So it's going to bring up my test cluster yet again. So there are a couple of things I want to show you as I'm going through this demo. Now this test cluster that I'm using is actually currently configured to just use a scale-out file server. So it doesn't have any disks attached to it. Now something that a lot of people miss is when we did shared VHDX in 2012 R2, we have actually always supported hot add of shared VHDX. So I'm just going to do a hot add in this demo, and I want to highlight two key changes that we've made here. The first one is just a usability change. So if I come here, you'll see we now have an item which is a shared drive. We didn't actually change the underlying architecture, but we got feedback from people saying that, like, it was a bit confusing the way you configured shared VHDX files. So we've made this just a simple, I want to add a shared drive. The next thing that you're going to notice is the file that I'm adding is a VHDS. We call this a VHD set file. This is a new type of VHD file that we're introducing, and it's necessary for some of the new shared VHDX functionality that we have. So if you have existing guest clusters using VHDX file, you can continue to use those VHDX files for shared cluster, for guest clusters. However, you will not be able to do the online resize and the host-based backup. We are providing tools to do a very quick and easy upgrade from a VHDX to a VHDS file so that you can take advantage of that. But I'm going to add this to my cluster, and then I'm going to come over here and say add disk. So I just want the first one here. This is going to come online. So just to highlight, this is all done hot, adding of a shared VHDX file. If I come in here and have a look, okay, it's a 40 gig file with a 40 gig volume on it. So I'm just going to run a PowerShell script. You can also do this through the UI, but PowerShell script that's going to increase the size of that shared VHDX file. If I refresh, it's gone up to 50 gig. Now I'm not going to do this because we're tight on time for this. I can now go in, I can use either PowerShell or disk management tools, expand that volume. I can do this all online. So zero downtime for any of this. The final thing I want to show you before I switch back to my slides is some work that we've been doing around hot add and remove when it comes to replica. So how many people here are using Hyper-V Replica in their environments? That's great. That was about half the audience. Replica is a great feature. I actually use it a lot in my environment. But one of the complaints we've received is like, hey, I love Replica. I love the fact that I can hot add and remove disks. But if I hot add and remove disks to a system that's running Replica, then it gets all strange, and I have to redo my initial sync and send all the data over, and it's a real pain. So we've done work to take away that pain. So I'm going to bring up this virtual machine, and it's got Replica enabled. And if you could have a look, you can see I've got a single virtual hard drive. It's currently replicating. So the first thing I'm going to do is I'm just going to add a new virtual hard disk to this virtual machine. So if I bring up the settings again, what you're going to see is it now has 2 hard disks. Now, what we've done is we have added that disk, but we haven't added it to the replication set. So by default, as you're using virtual machines, you can add and remove disks, and it will have 0 impact on the ongoing replication. Now, once I've added it, maybe that's a disk that I also want to have replicated. So there we have a PowerShell command called set VM replication -replicated disks. So I can run that, and I can say, hey, I want to add and remove virtual hard drives from the replication set. So I'm going to run this command in my script. Wait a moment. And then if I bring this up, you'll be able to see, okay, that disk is now in the replicated set. And the great thing is what's happening now behind the scenes is Replica is simultaneously doing an initial replication for that new disk, but continuing to do the ongoing replication for the existing disks that were under protection. So this just makes it a whole lot more flexible and reliable. So, switching back. And just to highlight, this is the commandlet to use for changing the replicated set. This is a nice little trick because you do set VM replication, replicated disks, and you specify disks. If you just want to say every disk in the VM, you can pass in the output from get VM hard disk on the virtual machine that you're replicating. So that's kind of all our storage availability stuff and cluster availability stuff. But there's a lot more that we've done to increase the availability of virtual machines. First, we're adding support for runtime resize of memory. This is really great to see. Actually, before I go further, how many people here are using dynamic memory in their environments? Okay. How many people have virtual machines that aren't using dynamic memory? How many people have ever been annoyed that they can't get memory utilization information for those virtual machines like they do for dynamic memory? Yeah. So we're allowing you now to A, resize memory on static virtual machines while they're running, but we're also showing you all the dynamic memory information. So even when you configure a virtual machine and say, I'm going to give this 2 gig of RAM, you can then go back and you can look at it and you can see, oh, its memory demand is 500 meg. Its memory demand is 3 gig. And you can actually start using those tools to size those workloads as well. So this is really exciting to see. Another thing, and Ronald, this feature is for you. So by the way, this is Ronald Beekler. Ronald was one of our first, actually one of the first 2 Hyper-V MVPs. And Ronald has been really mad at me because a long time ago, I showed him a pre-release version of Hyper-V that had hot add and remove of network adapters. And we never released it. And he's been so angry at me. We've finally been able to get around to get the right testing and coverage in place. So we now have hot add and remove of network adapters as well. So that's for you, Ronald. So let me demonstrate these features. So here I have a Windows 10 virtual machine. It's configured with static memory with 1 gig of RAM. If I come in here, you can see, okay, I've got 1 gig of RAM. Now, it is very easy now for me to change this. I'm just going to come into settings. I'm going to, let's say first, I want to take some memory away. I'm going to say 800 meg of memory, hit apply, and immediately you'll see, oh, we just lost memory. Thank you. So there is a little glitch here. You'll see that this memory counter says 797. This memory says 800. This one doesn't change down. We're working with the task manager team to try and get that fixed. But the memory's gone. And they get it right in like 2 out of 3 places. But if we go on the flip side, we can go up, and that does actually correctly show everywhere. So I've now gone down and up on a static virtual machine. So that's memory. Network adapter, similarly easy. You know, I just come in here, so this virtual machine has 1 network adapter. I can come here and I can say, add a network adapter. And there it is. And I can keep on adding network adapters. To my heart's content, I can have all the network adapters in the world. More network adapters. And then I can say, actually, no, that's crazy. I don't need all those network adapters. What was I thinking? Getting carried away on stage again. And I can go ahead and remove them all. And they're so nice, simple, flexible, and just making it so you never have to turn a virtual machine off for any of these operations. Thank you. So, I've got to switch back. But that's not all. We're doing more for availability. This is kind of our obsession, is figuring out everything we can do to make it so you never turn a virtual machine off. So we've done a huge amount of work to enable rolling cluster upgrade with the next release. So we actually have an entire session on this, which they've put on the last slot on Friday. And I will be here presenting on the last slot on Friday. So please come. But we'll be talking through the entire process for this. One of the things I want to highlight is that, and to me this is really cool, not only are we enabling you to do a rolling cluster upgrade in place, but we've done a huge amount of work to make sure that if you encounter any problems, you can roll back at any time. So, and we've actually tested this. What you can actually do is you can take a cluster running Hyper-V 2012 R2. You can upgrade every node in the cluster to the Technical Preview 2 build. You can have it running for a couple of weeks, and then if you find like, oh, I need to get an updated driver, and they say it's not going to come out for 2 months, or if there's any issue that you hit, you can actually roll the entire cluster back to 2012 R2 with 0 downtime. So that is really exciting. Now, in order to enable this, we've actually had to make a whole bunch of changes to the way Hyper-V handles virtual machine upgrade and compatibility behind the scenes. So let me talk about those, because this actually enables a whole bunch of interesting new things. So in the past, whenever you upgraded Hyper-V, the moment we saw your virtual machines, we upgraded them. It was, in fact, the way the code was written, this was so frustrating because we'd have people hit issues. The way the code was written, we would upgrade a virtual machine before we even knew there was a virtual machine there, and there was no way for us to tell that that was a virtual machine that we had just upgraded. The code was written so we did not even have the mental concept of a virtual machine from a previous version. So we've gone in and we've changed this. So we're now adding the idea of a virtual machine configuration version, and it is now a manual upgrade. So if you bring a virtual machine in, we do not automatically upgrade it to the next version. It is a manual process. So I'm actually going to quickly step you through what that process looks like and talk about some of the reasons why you would upgrade your machines and the reasons why you wouldn't upgrade your machines. So let me bring up Hyper-V Manager. And what you're going to see in a moment, and I'm going to start the upgrade script. So first thing to highlight is we're now reporting the configuration version. And everyone gets confused because they're like, configuration version 5? Like, where does that number come from? We've actually always internally had a configuration version. We've never shown it externally because there was no particular reason to show it externally. So version 5 is the configuration version for 2012 R2. And a lot of people say, but 2012 R2 is like the 4th release of Hyper-V. The short answer is we changed the version based on the functionality, not on the release. My personal favorite version would be Virtual Machine version 2.1a, which it was a real version. You might wonder why we had version 2.1a. For the curious, 2.1a is Windows Server 2008 R2 Service Pack 1. Because we actually had a problem with that, was in that service pack, we introduced dynamic memory. But we then had the problem that, what do we do if someone has a cluster where half the nodes have Service Pack 1 and half the nodes don't, and they enable dynamic memory, and how do we check for this? And unfortunately, at that stage, we did not have correct version checking in for our configuration version on the virtual machine. Our glorious solution to this terrible solution, we actually found a bug in the version checking in 2008 R2 pre-Service Pack 1 where it couldn't handle non-numerical characters in the version. So we fixed that bug, and we made a version that previous builds of Hyper-V couldn't see. So that was 2.1a. We've had 3.0, 4.0, 5.0. 5.0 is 2012. Right now, the technical preview 2, the virtual machines are version 6.2. So, wrong mouse. If I look at a different virtual machine, you'll see version 6.2 right there. But for this old virtual machine that I have, what's the process look like? Well, first I want to show you, I've built this across, and I've got full functionality like I have in 2012 R2. So everything continues to work, and this is a fully supported configuration. You can keep compatible virtual machines around for as long as you need. But if I do want to upgrade it, what I need to do is I need to shut down the virtual machine and do a manual upgrade. And this is a one-way process. So I can either do this through PowerShell or through the UI. In the UI, you can see I've got this upgrade configuration version. In PowerShell, I've got this command. You're going to get a confirmation prompt either way because it is a one-way process. So I'm going to do that. It's very quick. And now I've upgraded the virtual machine. So why would you upgrade and why would you keep the same? Well, obviously, you need to upgrade to get all the new features and functionality. So a lot of the cool features that we're showing you today, you're only going to get those if you're running a 6.2 virtual machine. On the flip side, if you keep a virtual machine at 5.0, we keep everything compatible with 2012 R2. We keep the configuration compatible. We keep the save state compatible. We keep the checkpoints compatible. Everything is still compatible. So even if you're not doing a rolling cluster upgrade, if you just have an environment where, hey, I have some 2012 R2 servers, and I have some Windows Server 2016 servers, and I know I want to move virtual machines between those from time to time, then just keep it at version 5, and you can always freely move those virtual machines back and forth. So very powerful and helps you with these mixed environments. So back to my PowerPoint machine. And this is the stage where Sarah gets to come back up on stage. And we get Sarah's car.
So about 50 minutes of solid information. How are you guys doing? Okay, cool.
So this is honestly, this section is Sarah and my favorite section.
Yep.
I'm the one who came up with the phrase operational improvements, which is just a terrible phrase. I'm bad at naming. Let's just establish that.
Yeah.
But really, when we say operational improvements, what we're talking about is we're talking about the things we've done to make your daily life better. Like these are, seriously, these are the little things where it's like, this isn't like going to change the world, but this is probably something that bugs you every day that you use Hyper-V, and we're going in and we're making it better. So to run down the list, and we have a whole bunch of things here. The first one is production checkpoints. I am so happy to be finally doing this feature. So let's do a show of hands. How many people here use checkpoints on their virtual machines? How many people love checkpoints? How many people use checkpoints on their virtual machines in production even though we've told you not to for the last 5 years? See, this is the point. So we built checkpoints for development and test environments. We told people don't use them in production. We shipped the first version of Hyper-V, and our #1 support call generator was people shooting themselves in the foot with checkpoints in production. In fact, I even got to have a meeting with the VPs to talk about why I was costing them so much money in support calls from people shooting themselves in the foot with checkpoints in production. So We have been working over the last couple of releases to slowly, incrementally improve checkpoints to the stage where we can say, okay, they're now supported in production. And with Server 2016, for the first time, we can give you the full checkpoint experience in a way that we stand behind and say, yes, this is supported in production. So really happy to do that, and I'll be showing you what that looks like in a moment.
Cool.
Now, Sarah.
Yeah, I want to talk to you guys about PowerShell. So we love PowerShell on the Hyper-V team. It's probably the most convenient server scripting and automation tool to come out in recent history. How many of you guys use PowerShell for automation? I think I know the answer, but just, yeah, that's kind of what I thought. So we wanted to make sure that your PowerShell experience is as convenient and as easy as possible. So now we're allowing you to do PowerShell directly from your host operating system to your virtual machine. No networking, no configuration, no hassle, no setup. It's just there, just works out of box.
It's absolutely beautiful.
So you'll see that in a minute. It's really cool.
So the next thing, and this is another one that I'm really excited about, is we've been working with the file systems team to start lighting up some of the advanced capabilities of REFS when you're using it with Hyper-V. And there are two big things we're doing here. So in the Windows Server Technical Preview 2 build, if you create an REFS volume and you use it to run your virtual machines on, you will get instant fixed disk creation and instant disk merge on your virtual hard drives. This is amazingly powerful stuff, and I'll be showing you what that looks like in just a moment. But first, we have one last thing for Sarah to talk about, and then we'll switch over to demo.
Yep, and Hyper-V Manager, we get people telling us all the time about how we never improve anything in Hyper-V Manager. We do have some changes for you. So I'll be talking to customers about a larger clustering scenario, some larger scenario. And they'll be telling me about how they do remote management with Hyper-V Manager, and they'll use remote desktop to connect to a remote host, and then they'll launch Hyper-V Manager. And we're just making that all go away. Now you can connect to a remote server using alternate credentials, so you can specify your credentials and just remotely manage your host directly for most things that you can do in Hyper-V Manager. You can also connect, by the way, with IP address and anything you need to connect with in case you don't have the computer name on hand.
So let's show all these features off.
Yep, so here you go, another solid block of demos.
Another demo block. So I start with production checkpoints, and then you take over.
I'm sorry we're just zooming through the content and demos today, but as you probably
we have 22 minutes left, and I still have demos.
And a lot of them. It's like
a lot of them. So, okay, demo system. Type in the password. So here I have my demo system. Before I show you production checkpoints, I'm just going to do a standard checkpoint just to highlight how the experience is the same for both. So standard checkpoint, I'm going to type something in, and then I'm going to take a checkpoint. And when I take the checkpoint, it's going to capture the disk and the memory state, which is great for a development and test environment, but is not a great idea for a server production environment. Because now if I, actually I'll close that and make a change. Now if I revert that, when we come back to the checkpoint, it's going to come back to exactly the point it was at when I took the checkpoint, including all the running code. Now, as I said, if you're in a development and test environment, you're trying to reproduce a bug or look into an issue, that's incredibly handy. But if this is a server, like if it's a SQL server, you don't want it coming back at exactly the same point. If it's an Exchange server, you don't want it coming back at exactly the same point, because they have operations in flight, they have network dependencies, they have all this stuff going on. So what I can do is I can come in here and enable production checkpoints. So I'm going to say only use production checkpoints. I'm going to type something else here, literally something else. And I'm going to take a production checkpoint. So here, the experience is exactly the same. I took a checkpoint, it's taking the checkpoint. If I go into Hyper-V Manager, I will see the checkpoint in the checkpoint tree. I can delete it, I can apply it, I can do all that stuff. Where things change is what happens when I apply this checkpoint. Because when I apply this checkpoint, what I actually get is first, you'll notice I'm booting up. Because what this checkpoint does is it uses VSS backup technology to create a Hyper-V checkpoint. And when I apply it, it's like I've done an instantaneous restore from a backup that I just took. And all the enterprise software that I have running in there fully understands what this means. So if you think about SQL, if you think about Exchange, if you think about these apps with standard checkpoints, when you do that, they have no idea what's happening. Like, hey, I just went back in time. I've got all this stuff going on. Like, what's happening? Whereas with production checkpoints, when I have those apps, I restore it, they come back and they're like, oh, I'm coming back from someone used VSS, and I know to replay my logs, I clean things up, and so on. So this allows you to do exactly the workflows that you do with checkpoints, but in a way that is completely safe for production environments. So super happy about that. So.
Cool. So I get to show you guys PowerShell Direct. This is probably my favorite feature, honestly.
By the way, Welsh is getting set up. The reason why we left, we saw that error once in practice, then we practiced again, and we didn't see it the next 2 times, and
we'll see what happens. Yeah. So very quickly, because my boss changed my password. This is the joys
of millions of demos.
Okay. So first, I want to show you guys a little bit about this virtual machine. Notice we have no NIC, we have no network at all. If I open my Windows features, you'll notice there's nothing out of the ordinary. It's just all of the default things that are enabled in a unconfigured Windows operating system. So there you go, I can configure Internet Explorer because it's never been launched before, and no network, vanilla VM, nothing running in it, no configuration. So I'm going to start configuring IIS using PowerShell Direct. And I just enabled our integration component for guest file copy. I actually set the execution policy correctly so that I can run administrator scripts and run arbitrary PowerShell. I'm going to dock that on the left. I'm waiting for IIS to be enabled. And I'm going to start IIS. So while our web server is configuring itself inside the host operating system, so there's nothing running in the guest operating system at all, I wanted to talk about one of the things we've been using PowerShell Direct for all the time. So actually, we've been using this to figure out what the state of the virtual machine is. So we've just been sending a command into the virtual machine and waiting for PowerShell to respond as a way of knowing what the state is of our virtual machine. Because if you write demos for Hyper-V, you know that we know when a virtual machine is running. We actually don't know anything about the situation of the operating system inside the virtual machine. And now we can use PowerShell to know a little bit more about that.
And the great thing is, all the demos that we're doing today, we've actually heavily used this feature to automate the whole build process for it. We have a single script that builds a domain controller, scale-out file server, multiple clusters, multiple workloads, and it's only about 200 lines of PowerShell code, because a single script, we're able to do stuff both in the host and inside the virtual machine.
Yeah, so remember, at this point, we have changed the execution policy, we enabled IIS, we've actually used the web server commands on the guest side, and this is from the host using PowerShell Direct, to load our website, start the website, change the content, and now if I refresh localhost, we will see my website up with any luck. Yeah, there we go. So there you go, that's my snazzy site. Remember, I've never run anything directly on the guest operating system this entire time. It's all running directly from the host.
We're getting errors from our demo script, and it's making us nervous. But this is okay. We shall keep on going.
Luckily, this ReFS demo is really cool.
This is really cool. It's also one of the ones that's failed when we've had...
We'll see what happens. At least half of it will work.
So I'm going to kick off this demo. And the first thing I'm going to do is I'm going to create a 1 gig fixed VHDX. This is the most boring thing in the world. Actually, let's have a show of hands. So the largest fixed VHDX that I have ever had to sit around and wait for it to create, personally, is a 5 terabyte fixed VHDX. Who has created larger than 5 terabyte? Okay, larger than 10? Larger than 20?
They're slowly going
Okay.
down.
We've got 2 hands here. Are there any other hands? We've got 1 up the back. Larger than 30?
Apparently, we
So-
have one crazy person.
Yeah, so what's the largest one you've created? 64. And how long did that take? Oh, you did it on ODX. So my 5 terabyte one, it actually took 22 hours. So this is going through, and I do want to highlight, for the NTFS REFS comparison that I'm doing, I have both volumes on the same piece of storage. So it is an apples to apples comparison, and to make this as unfair as possible, my RAID device for this is the world's fanciest setup. If you see it, I have 2 USB disks tied together with hairbands. And those are running SATA 2 spinning disks.
Enterprise grade storage.
This is the slowest storage space I could create for this demo. So on this storage, a 1 gigabyte fixed disk on the NTFS partition took 71 seconds. Now, same hardware, same operation, different partition, formatted with REFS. Let's create a 1 gig fixed VHD. 4 seconds. That's a bit faster. So what if I want to create a 50 gig fixed disk on REFS? Let's see. Oh, 3.9 seconds. So it doesn't matter the size of the fixed disk. So that's fixed disk creation. Now let's talk about merge, and this is the one that failed once in practice. Let's see what happens. Do I get to merge? Does it merge? Yes, it's starting to merge. So this is another slow one. So when you have differencing disks and you need to merge them, this is a long process today. And this actually probably happens to you more often than you think. Obviously, now, how many people here manually use differencing disks? Like you create differencing disks and you use that in your environment. So we got a couple of hands. But if you use checkpoints, and I know you all do, when you delete them, we have to merge that back in. If you use replica, and I know a whole bunch of you do, when we do the initial replication, we create a checkpoint, and when it's completed, we have to merge it back in. We use this sort of technology also as part of our backup story. Now, not only is merging on NTFS slow, as you can see, it's taking a while. By the way, don't worry, the progress bar is not linear, thankfully. It spends a lot of time in the first 10% and then, bah, see. Not only is it slow, but this actually thrashes your disks. Because to do this, we are copying byte by byte all the data. And as you can see, 68 seconds. So I have exactly the same files that I just merged. Literal same copy on an REFS partition. And let's see what happens if I merge those.
Hey, it works.
And 6.9 seconds.
There you go.
That's pretty cool. But let me tell you, the speed isn't the exciting thing. The exciting thing is we did that with 0 data copy. So there's no data thrashing happening on the back end. It's very quick, very low impact, and it makes it amazingly powerful to use these technologies. And it worked.
It did work. So you have to know when we hit the error that flashed on the screen earlier today, it made that demo absolutely fail. So
Yeah, there was a file locking issue when we did that earlier today in practice. So now, do you want to quickly show off remote management?
Yes. So I forgot to say this earlier, so I might as well say this now. What we actually did on the back end here is we made Hyper-V Manager use the same remote management story as SCVMM and PowerShell. So we're actually now, if you use alternate creds, working with Cred SSP, just like SCVMM, and if you have PowerShell remoting. So let's try this with my default credentials right now, just to prove I'm not actually inheriting credentials the way I would have in the past. You can see that I got an error for using the wrong credentials. Let's try with my Hyper-V administrator credentials. Now, the intimidating part where you get to see if I can type my password on stage.
At least you got the username right.
Yeah.
That was the mistake I made.
Oh, okay.
And you're good, yeah.
I have to press OK,
Yes.
it turns out. Oh, fat fingered it.
Oh,
So earlier today, I did that like 3 times. So if I don't get it right the next time, then I'll just
it's okay.
give up.
People always type their password right when they're under pressure after a failure on stage.
Oh, yeah, I know.
It's a good luck charm.
Yes. Also, if I press tabs, I hit OK.
Yes!
Bam. And just to
So-
prove that this actually is running Hyper-V and running correctly, we do have virtual machines running on that host.
Fantastic. So there are a couple of things you want to say also about cross-version management.
Yes, so while we're talking about Hyper-V Manager, we have down-level management inside Hyper-V Manager. You can connect to your Windows 2012 machines, or your Server 2012 machines, as well as your Server 2012 R2 machines. Same UI, all looks good, all works seamlessly. We have 2 versions of PowerShell now, so you can specify whether you want to use PowerShell version 1.1 or 2.0. In the background, what we've done is refactored PowerShell to use the same underlying stuff as Hyper-V Manager. It makes it much easier to add commandlets for us, but it does mean that there are 2 modules that you can choose from depending on what you want compatibility to be.
Now, you've also been working on some of the changes to how we do integration services.
Yes. So again, speaking of Hyper-V Manager, and many of you guys have actually already noticed this, if you go into the VM Connect window and you look in the Actions menu, there used to be a thing that said Insert Integration Components Disk, something along those lines. It's gone now. It's just absolutely gone. In talking to customers, they were telling us that as their deployment got bigger and more complicated, it became increasingly more difficult to update integration components by logging into the virtual machine, mounting a DVD, opening the DVD, installing the integration components, and that entire process just became a hassle. So what we've done in 2012 in technical preview, Windows 10, and going forward is the integration components are actually available through Windows Update. They are set as a critical update. They apply to virtual machines running on the correct version of Hyper-V. They just all handle it for you. As long as you're getting updates inside your virtual machine, they are there, and you can install them using Windows Update services or whatever else you're using to keep your virtual machines up to date. So that's all just handled for you.
So I have 2 sections left, and I have to absolutely fly, because we
have 7 minutes.
We have 7 minutes and 46 seconds. I've got a big, bomb going off timer right in front of me. So, working better at scale. There's a bunch of work that we've done in this release to make it so that Hyper-V works better as you scale up the number of virtual machines and the number of Hyper-V hosts. So we're doing a huge amount of work evolving the Hyper-V backup platform so that as you get hundreds, thousands of virtual machines, the backup is going to scale with that. And as I mentioned earlier, we're working closely with all our backup partners on this, so I would really encourage that you reach out to them and start saying, hey, I'm trying out the technical preview for Server 2016. When can I get early bits for your stuff so I can try this out together? One of the things that we're really happy about in doing this is that we're also building in change block tracking into the platform. Now, what this means is that it's no longer necessary for backup partners to develop kernel mode filters that run in the parent partition. This means you have less stuff installed in your parent partition, and it increases the reliability of the system overall. We've also made changes to the configuration file. This is not something that I normally talk about. In every release of Hyper-V that I've ever been involved in, we actually do a huge amount of work tuning and tweaking the virtual machine configuration file. And you may think, what's the deal? It's just a virtual machine configuration file. Well, by the time you have thousands of virtual machines stored, you have thousands of configuration files, starting to see failures in that any error case becomes a problem. One of the great things I like to talk about is I like to say, so let's imagine I said, hey, we've seen under load that we see configuration corruption on Hyper-V about 0.02% of the time. That doesn't sound like much, right? Pretty small number. So let me highlight, Azure runs on Hyper-V. 0.02% of Azure means I'm getting phone calls every day. So we have been working hard to figure out how to make our configuration file resilient and scalable. Normally we don't talk about this. I am talking about this because we made a big decision this time, and that is we're actually moving away from the XML format to a binary format. So we have, on one hand, we have never supported people opening our configuration file with Notepad and editing it, but I know that you all do. So that now no longer works. Sorry. However, you should be able to do everything through PowerShell. And I've been telling people, if there's something that you do not think you can do through PowerShell, come and tell me and I will show you that you are wrong. No, I will help you figure out how to solve this. But that's just a heads up. The final thing I want to talk about in this section is Hyper-V cluster level management. This is something that we're starting on and that I'm really excited about, is we're actually taking our management layer and bringing it up to the cluster level so you can start to manage an entire Hyper-V cluster like it were just one big Hyper-V server. So this is something that's a lot of work for us. So there's just a little thing I can show you in the Technical Preview 2 build that shows this in action. So here I've got a PowerShell window. I'm actually using PowerShell remoting. I'm connected to a cluster node. And if I run get VM on this, actually I haven't PS'd in yet. So that's just running locally. I need to do that.
3 minutes.
3 minutes.
3 minutes.
It's okay. It's just Marcus Sinovich next.
Yeah. Type all your passwords right the first time.
No one wants to listen to him. I mean, we've all heard him before. So if I run get VM, you'll see there's a single virtual machine there. But if I do get VM computer name, and I actually point it not at a computer, but at my cluster, what it's going to do is it's going to return all the virtual machines on the cluster. So I didn't have to do anything to set this up. This is just there because I created a Hyper-V cluster. I can now take that and pipe that output into all our various PowerShell commands. It makes it a lot easier to start operating on a cluster of Hyper-V using PowerShell. You don't have to go looking for and finding virtual machines. So, in 1 minute, enhancing the platform. Thankfully, this section doesn't have any demos, so I can jump through this. We've made a whole bunch of improvements around Hyper-V power management. Why have we done this? Because of this.
Hey,
this is all the people on Twitter complaining about Hyper-V causing connected standby to not work on their Surface 3 Pros. And I want to highlight this last one here. That's the Microsoft Surface account telling someone to uninstall Hyper-V. That hurts. So connected standby now works. Windows 10, Windows Server Technical Preview, you can put it on a device that supports connected standby, and it works. We've also made improvements to remote effects. It supports OpenGL and OpenCL, and we've increased the amount of VRAM that you can configure for it. So the final thing, and this is a fun thing to do, I got HR approval to do this on Sunday, is to say, that's all our content, but we are hiring. So if you are interested, if you know someone who would be interested, here are some links. And with that, we have 9 seconds to answer questions. I will answer questions until they kick us off stage. But thank you, everyone. Mm-hmm. And please go get the bits, play with the bits, tell us what works, what doesn't work, what you like, what you don't like, fill out evaluation forms.